patching and applying security patches and things like that. That's one. You want to get rid of some of the technical debt. I think this point about high cost of ownership is important, because today, maybe this application is running in an on-prem VM environment or IaaS, and you are having to spend some amount in managing and patching this application. Okay, and then the last reason, don't underestimate this reason. I've talked to many companies in the last 2 or 3 years. They are evacuating their data center because they're moving to the cloud. They're taking some of the applications, maybe developing them in a cloud native manner, but then also take the line of business applications which they don't want to run anymore, and they want to simply evacuate. Okay, so one more concept slide here, which is how do you typically take your applications and migrate to a public cloud provider, right? And Gartner calls it a 5R model, and I've only shown you 4 R's here. So one is lift and shift. You take your VM and you migrate that VM over to the cloud. Of course, that works. We know that works, but that does not allow you to take advantage of the capabilities that cloud may offer. The other R is the refactor, where you can take that application and maybe start taking advantage of some PaaS capabilities, maybe run it inside app service, right? You leave other pieces the way they are, take the web piece, run inside an app service, or maybe take your database piece and see if it can be run in a database as a service capability, Azure SQL database, or MySQL, or something like that, right? And then of course you have the other R, which is the Reimagine, which is you're trying to build this application natively as a microservices-based application using, from the ground up, or maybe in a serverless manner using event-driven functions and things like that. And then, of course, there's this option of replacing your application. Maybe you don't even need this application to be a custom application, and you want it to be some sort of a SaaS application with some low-code development model. And if you're wondering what the 5th R is, it is, of course, retiring applications, doing a portfolio analysis, and seeing that there are some applications that you absolutely don't need. Okay? That's the retire piece. What I'm here to talk about is another R here, which I call the lift and reshape, which is becoming important in my mind since the Windows containers have become available. Okay, so let's compare the approaches. So in Rehost, keep in mind that we are not changing the code at all. So the code changes are none, but our operational costs are still high because you're running the VMs, you still have all of the overhead. And look at the far right there, the SRE maturity. The site reliability engineering maturity is low because you still are dealing with the VM level. And then I should say that the costs are high because even though you are paying for the entire VM, your VM utilization typically what we find is about 10-11%. Okay, so that's Rehost, Refactor, Reimagine I already talked about. And then what I'm here to talk about specifically as part of this session is the replatform, where the code changes are low, the operational costs can be reduced, and mainly because you're taking your existing application, the Windows application, you're containerizing it, and the operational costs are low because you're not in the business of applying patches necessarily. That's one way of reducing the operational cost. And the other way of reducing the operational cost is when you're running on top of an orchestrator like Kubernetes, you have capabilities like health checking available to you. So if the container is unhealthy, you want to add another instance of the pod or a container, Kubernetes can do those things for you automatically. It can also apply some memory constraints and say only this much memory is allowed or this much CPU is allowed. So you have some way to manage that in that manner. The other reason the cost is low is because you're doing a higher density deployment. So you can have one VM, but you can host multiple applications because now you have the ability of not just isolation, but also the ability to apply quotas on top of that. Okay, so that's the high level point about what we are trying to accomplish as part of this session. So I want to talk about the replatform here. Okay, so I'm going to shift gears here a little bit. Let us talk about Windows containers next, because most people who work with containers are very familiar with Linux containers. So I want to take a few moments to talk about Windows containers. Okay, First and foremost, I think this should be familiar to everybody. So you have this notion of an image, which is an immutable copy of your application. So you take your application binaries, you take your dependencies, you create an immutable copy of that, and that's what a container image is. And then you run this image on some sort of a container host, and typically you store these container images in some sort of a repository. It could be a Microsoft container repository, it could be an enterprise repository that you have. Now, your image is broken up into layers, and this is an important concept to understand, that at the bottommost layer is the layer where you have the operating system mapping. So it could be a base container image, server core or nano server, and I'll explain the differences between nano and core in a moment. And then on top of that, you might have some other layers, and on top of that, you might have your application layer. This is an important concept to understand because these layers get cached and only the layer that is changing gets deployed. So this is an important concept to understand here as well. Okay, so when we talk about Windows containers, there are three types of containers. Now, keep in mind that Linux, for example, always had the notion of containers because Linux was based on this idea that the kernel is really small, and then the notion of namespaces and change groups has existed for a decade or more in the Linux side. On the Windows side, the operating system shipped with not just the kernel, but all of the Win32 or Win64 DLLs. So the notion of containers was not there until Windows Server 2016 came along, and Microsoft created this notion of containers. Okay? So because of the differences in how Linux and Windows operating system is based, there are differences in images here. And when we do a demo, we'll get into a little bit more, but it will suffice to understand that there are three types of container images. So you have a nano server image, which is about 100 megs in size and typically used for .NET Core applications. Then you have server core image, which can give you a full .NET framework support, about 1.5 gigs, and they've brought it down some, so closer to a gig. And then, of course, you have the Windows Server image, which gives you a full fidelity experience. Okay? This came out with Windows Server 2019. Okay? All the images can be run in a process isolation mode and Hyper-V isolation mode. What do I mean by that? So you can either run the container as a process. So one container is one process, another container is one process, or you have the ability to take each container and run it in a Hyper-V isolation mode. So if you're trying to run, if you want a high level of security, then you typically want to run it in a Hyper-V isolation mode. Okay, and I have to point out that right now in Kubernetes, AKS, the Hyper-V isolation is not supported, only the process isolation is supported. Okay, moving on. So at this point, let me just very quickly talk about the architecture of a Windows container versus a Linux container. In fact, let me just bring up the Linux container first because you're more familiar with this diagram here. So we'll start at the bottom of this diagram. So you, of course, have the operating system. And remember, I was talking to you about the notion of control groups and namespaces. These are all first-class objects in Linux that give you isolation. And to be very specific about it, when you, on Windows machine, on your laptop, when you go to the task manager, you see all the processes, right? You're seeing the processes for all the processes, system and user processes that are running on your machine. The notion of control groups is that you get a logical isolation of the process tree that belongs to you. And that concept did not exist in Windows before 2016 came along. So you have control groups, you have namespaces on top of the operating system, and then you have things like the containerd, and then on top of that is the Docker engine, and then on top of that is the Docker and the REST API, and on top of that are things like the Docker client. Okay, so that's the architecture on the Linux side. Let's go back to look at the Windows side here. Okay, if you look at the Windows side, you see here that you have the operating system, and now we have this notion of namespaces that was added in Windows 16 and then enhanced in Windows 2019. okay? And on top of that, this is the beautiful part in my mind, because of the partnership between Microsoft and Docker, they were able to keep the syntax the same. Of course, under the covers, a Windows Docker image is very different from a Linux Docker image, but all the commands that you use to start the Docker container, all of those commands are the same across Linux and Windows. And I think that's a very important thing that happened, because it takes your same skills. If you've been working with Linux containers, you're able to take that skills over to Windows as well. And then, of course, you have the Docker client up at the top. Okay, so this gives you a good understanding. Very quickly, I'm not going to spend too much time on this. I just want to explain this. Windows, of course, if you look at Windows operating system, it is broken up into the kernel mode and the user mode. Okay, that's where the hardware abstraction layer is. That's where the kernel hardware abstraction layer is. Now, so if you look at the Windows containers now that we have an understanding of how this is set up, this is where the Windows containers show up, right? So you have the hardware abstraction layer, of course, the hardware, the kernel. On top of that are the containers sitting there on the Windows operating system. And of course, the left-hand side of the diagram is based on the process isolation model. Remember, I was talking about that. And on the right-hand side, you still have the containers, but the important difference here is that each container gets its own copy of the kernel, because each container is running inside a Hyper-V isolation mode. Okay, so those are the two types of containers. I just want to have one other slide, because this is a common question that I get. Every container, so you might be running several containers on a Windows operating system. Each container is sitting inside its own network space. And this diagram sort of gives you this idea here that I have a Windows container, I get my own IP address, and then the other container gets its own IP address. And of course, the host shown at the bottom of the screen gets its own IP address as well. Okay, so I think we have covered the fundamentals. And the reason I went into these details, if you're probably wondering, why did you go into these details? The reason I went into these details is when you start migrating your application into Windows containers, you are going to get these kinds of questions. So, for example, hey, Vishwas, I have a .NET 3.0 application. Can I containerize it? Oh, I have an application that is using MSMQ. Can I containerize it? Or I'm making a pinvoke call into Win32 API. Can I containerize it? So these are the kinds of questions that I get very often. And the best way to think about this is, what is a container ultimately? A container image is nothing but an archive file, which is a read-only archive file, which has all your application binaries and all your dependencies. That's what a container image is all about. Okay, there's nothing more detailed or complicated about that. Okay, now what is a container runtime? When you're starting a container, what is happening? Essentially, you're creating a job object in the Windows. Okay, so you're essentially running, think of this as a collection of processes that are running. So as long as your application can run on the operating system, whether it is .NET 3 or .NET 4, it will run inside a Windows container. The only challenge that you will run into is if your base image is 2016 and you are trying to use some OS level capability, which is only available in 2019, then your application will not run. So the best way to answer this question is, do my application or my application dependencies, are they dependent on the version of operating system that is before 2016? Because containers didn't even exist before 2016. So I'm trying to move some legacy application which was written in 2008. That would work fine as long as it's not dependent on some capability that has been deprecated. Okay, so I wanted to give you this intuition of how to go about converting this application. Okay, a couple of minor details to think about. So you have a container image. It has its own OS version. You have the host that has its own OS version. Okay, and if those versions don't match, you might run into trouble. Typically, when we talk about version numbers, there are 4 parts: major, minor, build, and revision. And you have to, this is one thing that you have to watch out. Your container version has to be compatible to the host version. Okay. So how does something like Patch Tuesday work? Okay, this is another very usual question that I get. Oh, so every Tuesday, every second Tuesday of the month, Microsoft issues a patch for the Windows operating system. What does happen to my container image? How will I get that? Well, what happens is right after Patch Tuesday, the same day, a new base version for the Windows container is created. Okay, and you can just redeploy your containers because, so the example here shown here is I'm doing a Docker pull command from the Microsoft Container Registry and getting the latest KB article number, which was published as part of the Patch Tuesday. Okay, so putting this line as the base layer in my Docker file will give me the latest patch for my application. Okay, I just want to do a quick check. Are you able to hear me fine? The video quality is fine so far?
Yes, both the audio and the video is good.
Thank you. Thank you for that check. It was just in the back of my mind. Okay. Thank you for somebody mentioned that as well. I appreciate that. I'm going to go into a demo here really quickly. So I'm inside a virtual machine in Azure, and I'll give you a little tip here. You saw in the previous slide that one of the challenges that you may run into is the size of the Docker image itself. If you have a nano image, it's about 100 megs. But if you're using a server core image, remember we looked at it earlier, that is about close to a gig. And downloading these images can be a bit of a challenge. And what Microsoft has done is if you go into the Azure portal, and if you try to deploy a virtual machine, they have added a virtual machine image in the marketplace where these container images are pre-cached. Okay, and I will, when I make these slide decks available, I'll give you the exact name of that image. So if I look here, Docker images, you can see that these images has been pre-cached for me, and you can see here that I have a server core image, I have a nano server image, and these images are available to me. Okay, so let's just see Docker ps-a, see if any Docker containers are running. So there's one Docker container running. So let me just try to grab this image right here. And then what I want to do, I'll explain this command here in a second. So what we are doing is we have already downloaded the Docker image. And the next thing we are going to do is Docker run in an interactive mode. And I'm providing the image of my Docker container. And I'm saying run the PowerShell command for me. Okay. And see, now I'm inside my Windows Docker container. So I can do a get service. So these are all services that are running inside my Docker container. Okay. And actually the better way to do that, if I remember the command here. So you can see I have about 114 services running inside the Docker container. And if I came here and let's just see get service, I'm directly on the host right now. So so the process count is different. And so right now, and if I go once again here, let's just do Docker ps-a. Wait, I'm inside the Docker container, so I should do this command. I should just come out. I can do this here. You can see right here that, let me move the screen a little bit. This is the Docker image that we just started here and about a minute ago. And this is our Docker image right here. And this is a complete, and see how quickly it booted up. I have a full fidelity operating system. Of course, I don't have, Docker images are not designed to have any UI. And one little sort of implementation detail here, that under the covers, even though the UI is not exposed, many of these applications, the UI, the session subsystem is actually available to you. So there are some interesting cases that people have done that, if you're trying to run a Docker container, if you're trying to do some image rendering, that can still happen. You just don't have access to the UI in this Docker container here. Okay, so we started a Docker container. They're using the same commands as you would use in a Linux container. So that's all working in the manner that you would expect. Okay, so that's the very simple Docker demo here. Okay, all right. So we completed a very simple demo of Docker container here. Okay, so now I'm going to shift gear a little bit. Now that we have seen what Windows containers is all about, we've talked about the types of Windows container images. Now let's talk about Kubernetes a little bit, because it does not help to just take our application and run it inside Docker, because who's going to be responsible for making sure that our container is constantly running? We are getting all the load balancing capabilities. We can run multiple copies of the container. Who's doing the health checking? All that is not available yet. All we have done so far is taken our application and containerized it. So let's talk about Kubernetes for a second. And many of you may be familiar with Kubernetes already, but if you're not, I'm going to do a quick introduction of that. So Kubernetes, of course, has taken the world by the storm, I should say. So there is a question there. Let me just see if I can quickly get that question. With the image tag and Patch Tuesday, does it mean you'll have to rebuild your images and redeploy them? Okay, okay, good question, Olga. So let me try to answer this question. So on a Patch Tuesday, and let me do this. I will answer part of the question here, and then when we look at the code, I'll try to answer the remainder of the question. So you are right. When the Patch Tuesday happens and the base layer of your Docker image needs to be updated, right? So you will need to rebuild the Docker file, rebuild the Docker image and deploy it. That is correct. But that is typically the part of the DevOps process, right? Docker containers typically, even on the Linux side, if you looked at them, the life of a Docker container typically on an average, unlike a VM, is small, 1 or 2 or 3 days. Typically, that's what we find. And then people are restarting these Docker containers. And because Kubernetes can give you a sort of a blue-green style deployment, running a DevOps process on every Tuesday, which rebuilds your Docker image and then redeploys the container in a blue-green manner, is something that most Kubernetes based organizations are already doing. So when we look at the code, I'll show you which line of code needs to change, but at a high level, yes, you will need to rebuild your images and then redeploy them. Okay, so let's go to Kubernetes back here. So Kubernetes has taken the world by the storm. If you are new to the container orchestrator scene, you probably missed an important battle that was taking over the last 3 or 4 years, where there were a number of orchestrators sort of competing. You had the Docker Swarm, you had Mesos, and you had, of course, Kubernetes. And by all accounts, Kubernetes seems to have won that debate, and people are increasingly sort of standardizing on Kubernetes. And the best thing about Kubernetes, and really we can go into sort of the technical merits of Mesos versus Swarm versus Kubernetes, but it is really about the community and the momentum that has really propelled Kubernetes into this position of prominence right here. Okay, so what is Kubernetes? So let me keep going here. Some key concepts for you to understand, and this is of course not a Kubernetes talk, so I'll just give you just enough concepts for my demo to make sense. So you have a notion of a pod. I've been talking a lot about containers, but think of pod as a collection of containers, a logical collection of containers. And let me give you an example. You might run a web server, or you might run a web application as a container, and then you might have a log aggregator as another container, and it would probably make sense to take these two container images and run them inside a logical boundary. And that's what a pod is all about. So that's a pod. Pods are ephemeral, which means they can come and go very quickly, what we were talking about a moment ago. So if the pods are ephemeral, you need something that is long running, and that's what a service abstraction is all about. Okay? And then you have a volume. Containers are stateless. They can come and go. How do you persist state? Well, that's how you mount. You can mount a volume. You can mount a volume to the host machine. So in my previous example, I booted into a virtual machine and I started a container. And I can say that when the container starts up, mount a volume to some disk drive on my host machine. Okay, that's a volume mount. But what we will see later, that in case of Kubernetes, because of the extensibility, so there is something called the container storage interface. Because of that extensibility, you can now mount things like an Azure disk or an Azure file as a volume, as a persistent volume. Okay, namespace, a logical, think of your cluster, Kubernetes cluster being broken up into a logical boundary, that's namespace. And then you have things like a replica set, which is a really important concept in Kubernetes. Think of this as a reconciliation loop that is running constantly. So you tell Kubernetes, hey, this is an important application. I want you to run at all times. I want you to run 5 copies of this container and load balance them in this manner. And then it is replica set ensures that this number 5 maintains. So there's something called the replica set controller, which will constantly look at this. So let's say one of the pod or one of the container dies. It will notice that now you have only 4 pods, and it will restart that pod for you. Okay? And then you have deployments, which is a way to package your application and roll it out in a version manner, roll back if you needed to. Then you have stateful set. So I've been talking about sort of stateless applications. What if you wanted to run MySQL on Kubernetes? You need a way to manage the deployment in a manner that works well with a stateful application. That's what a stateful set is. And then, of course, you have a daemon set. Okay, it's a very quick introduction to the concepts, because I'll need these concepts when I show you the demo later on. Okay. One more concept slide here, and this is probably my favorite slide in terms of explaining Kubernetes. So on the left-hand side of the screen, the blue box is the control plane of Kubernetes. This is where your API server is. This is where your etcd, which is your configuration database is. And then, remember we were talking about the reconciliation or the persistent set controller. That's what the control manager is. And then scheduler, of course, is responsible for, hey, Kubernetes, go deploy my Windows container there. Scheduler is going to go find the right node that can run your container and dispatch that container to that node. Okay, so the blue box here is something that Microsoft provides you for free. And at Build Conference 2 weeks back, they started talking about an SLA-driven control plane, which will cost you some money, but will give you higher SLAs. So you'll have both the options there. Okay, the green boxes are the ones that you pay for. These are the machines that you pay for. So this is where your containers are going to run. So how many green boxes do you need? Well, depends on how many workloads you're running. And remember, I was talking about the cost of running this is lower because you're paying for the 2 green boxes, but you can package as many applications as you want. And each pod has a memory and a processor quota associated with that. Okay, and on the right-hand side of the screen, so we've looked at the blue box, we've looked at the green boxes. On the right-hand side of the screen, you have the load balancer, and then you have the dotted line there, where once again we are using the Kubernetes extensibility. So you have the first-class notion of a load balancer in Kubernetes, but then it gets mapped to Azure Load Balancer. So that's the benefit of working with a service like AKS. I can just say, hey, I want a load balancer, and then I can get internally, it'll provision an Azure internal load balancer for me. And then, of course, to the far right of this diagram are your end users. They're coming in with a load balancer. Load balancer is redirecting them to one of the pods running on one of the nodes here. And then the blue box is maintaining the health of this application. If one of the pod dies, that's what the blue box will make sure. Okay, so in terms of Windows, what pieces of Kubernetes are running on Windows Server and which pieces are running on Linux? And that's the purpose of this slide right here. So the green box in this diagram right here, sorry, the blue box in this diagram is still a Linux node. The approach that Microsoft has taken, well, they could have gone with implementing even the green boxes on Windows, because all of the Kubernetes is written in a programming language called Go, and Go is available on Windows, so they could have ported. But what they've tried to do is all of the Windows node are focused on running kubelet and kubeproxy. And let me go back here. I don't think I explained kubelet. So if you look at the green box there, there are pods. Right underneath the pod, you have the container runtime, and underneath that is the kubelet. So think of kubelet as an agent running on this node, which is responsible for taking instruction from the scheduler and launching your containers, right? That's what the job of the kubelet is all about. So in this case, what Microsoft has done is implementing a node inside the Kubernetes cluster, and they've implemented the kubelet, so that agent on the Windows machine. So how will this work? Let's look at this. So typically what I'll do is I'll create a Kubernetes cluster. So you can see here, I'm creating a Kubernetes cluster, and let me get myself a laser pointer so you can look at this better. So right here, I'm creating an AZ AKS cluster, and I'm creating a cluster with node count 2, and I'm providing some details here. And the next thing I can do is I can come to the same cluster, and now I can add a Windows node to that. So think about this. I have a going back to this diagram right here. So think about this. I have a cluster control plane, which is running a Linux node, of course, and that's provided by Microsoft. I might have a Linux node pool, which is this, let's just call it this green box here. And then I have a Windows node pool right here. Let's just call it the node 2 here. So what's going to happen? Now, I can come in and say, please deploy my application. And then I can specify some attributes which will inform the scheduler that, oh, you're talking about a Windows container. Let me send your pod to run on a Windows node. And the next time you come in and say, hey, I want to run another application, and that application has certain attributes, which will then be run on node 1, which is a Linux node. Okay, so hopefully that part is clear of how Microsoft has implemented Kubernetes on top of this. Okay, so at this point, I'm going to jump into a demo. But before we jump into the demo, let me just show you the high-level architecture for this application. Okay, so this is the application that I'm about to demo you. And you may remember this. This was a sample application that Microsoft built back in, I think, to 2010 timeframe. I think it came around with when .NET 3 or 3.5 was available. And some of you may remember it is called the Music Store application. So when I was trying to learn Windows containers almost a year ago, or slightly more than that, I took the Music Store application and I converted it over to run it in a container, and then I made it run inside Kubernetes, and I was showing it to my colleagues and saying, look, it's so easy to take this Music Store application and then run it in Kubernetes. And then the feedback I got from my colleagues was, of course, you were able to run it easily. This is a toy application. It has just a bunch of ASP.NET pages, and you were able to convert it. And how does it show us that this technology can be used to convert more complicated legacy applications. So I said, okay, feedback taken. So what I did was I took Microsoft's 2010 sample, and then I added some complexities to it just to prove that these kinds of things can also work inside Windows containers. So even though the application was MVC-based application, I added some web forms, I added WCF modules to it, I added MSMQ, I added some Windows service, I added a file watcher piece. I added this because I was going through Stack Overflow and people were complaining about some file watcher piece with Docker on Windows, so I added that. I added some C++ library that is being invoked by using pinvoke inside my .NET application. I added an HTTP module, and then I finally added some log4net. So what I did was I said, okay, let me find 8 or things that people are complaining about or finding challenging, and I'm going to add it on top of the music store application, and I'm going to then demonstrate to people that this can work. Okay, so that's the idea here. And let me show you the architecture. So imagine that your music store application is running in an on-premises environment. It's a very simple application in terms of some IaaS boxes and database. And then when we convert it over, it is running inside AKS. Okay, so at this point, what I want to do, let's go into Visual Studio Code here, and let's just walk through some of the interesting parts of this application right here. Then we will see this application. So I'm going to, there's a lot happening here. So I want to reduce some of this clutter here for you, and then I can show you this application right here. So the application itself is not very interesting, and this is a bunch of it has some MVC controllers, of course, and that's not very interesting by itself. I'm not going to go into that, but I have also added some web forms inside this. I have added some web form capability right here, and so this is your essentially the ASP.NET application. Okay, the first thing we need to do is we need to convert this application into a Windows container image. Okay, and let's look at this file right here. Let me get myself a little bit space here, and then hopefully you guys can all see this. Okay, so the first step in converting this application over to a container is to figure out what are the base layers you're going to need and what are the application dependencies that you're going to need. So here, since this is an ASP.NET application, I started with a base image. So notice here that I'm not using Windows. This is right here. I'm using this server core image, right? Because I'm using the .NET framework full here. You guys can see my screen. Sorry, did I get a comment here? Let me just make sure. Yes, you can see my screen. Okay, so I saw a comment flying by that made me worried. Okay, so the first thing I do is I get the base layer, and then I copy all the www root binaries in there, as you can see here. And then I am also doing some things like applying certain permissions. So this is a Docker file. This is what I was talking about will run as part of my DevOps process. And this will generate a Docker image for me. And then I have some other things here that are going on. Notice here that I'm not using Redis cache. I'm using a memcached. That's what the caching technology I'm using. So in this case, what I do is I run a scheduled task. So when my container starts, I'm going to start my memcached instance. Okay, and this is not a best practice, right? I mean, you can. There is something called the Redis cache that is available on Azure, and you might want to take advantage of this. But again, keep in mind that I was trying to show that you have a lot of flexibility when you're designing these Docker applications. You have a lot of flexibility. That's one application. Let me just show you maybe another. And here you can see I have some web form applications and things like that right here. Okay. Let's look at the WCF application here. In the WCF application, let's look at the Docker file here. And here's the Docker file. And once again, I'm copying some commands. I'm running some permissions and things like that. And I'll make this code available so you can, and in this case, I'm assigning some permissions because I needed to give a certain attributes for this application to work. So once you understand how this Docker file works, and by the way, 2 weeks back at Build Conference, Microsoft announced something called the Windows Admin Center tool. I think I have a slide here somewhere. Let me see if I can easily pull that up for you guys. Yes, right here is the slide. 2 weeks back, Microsoft announced something called the Windows Admin Center, and this and you can download it right now. And what Windows Admin Center does is you can point to your application and it generates the Docker file for you right here. So you might want to take advantage of this here. Okay, so just wanted to show you that. And now that we have looked at some of the application parts, so the application itself is not very interesting. It's a standard ASP.NET application. The interesting part is all the Docker files. I'm just trying to see if any other Docker file that I want to show you here. So I think I've showed you this. I've showed you this one. Let's see if I can bring this up. This is another version of the Docker file. I'm just trying to see if there's anything interesting going on. Once again, I have the base image here. I'm running certain actions. And here I had to install an optional feature. Yes, yeah, I think this is worth talking about. I needed the MSMQ ability. And when Docker containers on Windows came out, MSMQ was not available. It has become available since. So you have to make sure you have the right image in place. And then I've enabled this capability right here. Okay, this is probably the hardest part, to know the dependencies and get it done. Then once you have it, it becomes a really simple exercise there. Okay, so the next thing I'm going to do is bring up my application right here. So right now I'm running. I just want to make sure okay, so it looks like that's running. So let's go back here. So this is my Kubernetes cluster. And right now, essentially, this is my container registry here. And let's see if I can just very quickly go into my cluster right here. So these are all my Kubernetes clusters running. So let's find the here. So this is my Kubernetes cluster. Let me go find right here. Let's go here. And this is my resource group. And inside that resource group, you will see that I have the Kubernetes service. Let's go there. And inside that Kubernetes service, it tells me information about, what version of Kubernetes am I running, and what are the node pools that are available. Let's look at the node pools for a moment. And you can see here, there are additional node pools available. Let me actually, the best way to show you also, let's go back here and go here. And when we look at Kubernetes, you really have two resource groups. One resource group contains the blue box that we were talking about, and the other resource group contains all of the virtual machines. So here, let me get myself more space here. And you can see here that I have, this is the Linux node pool right here, and this is the Windows node pool right here. Okay. All right, so I think I've shown you these pieces right here. I want to take the time to also show you all of the manifest files. And this is where the Kubernetes manifest comes into play. Okay, so let's just walk through this application right here. Okay, so this is a Kubernetes manifest. This is how you talk to Kubernetes. Basically, I'm saying, hey, Kubernetes, create me a deployment. And the name of the deployment is this. And these are the number of replicas I want. In this case,
here's the top search result.
These are the number of replicas I want right here. And then this is the interesting part to note here, right? So I'm telling, remember I said that you can go up to the Kubernetes and say, you want to deploy this application to Windows or Linux. So in this case, I'm saying my node selector is Windows. My name of my container image is this right here. And then remember the Docker file we looked at? I ran as part of the DevOps process, the Docker file, and that Docker file was stored inside the container registry right here. This is the version of my application. And once I supply this manifest, so this is one of the manifest, this will, and then I need some secrets. Those secrets are being pulled from this location. And then that was the deployment object right here. If I go further down here, this is the service object. And remember, we were explaining the concept of a service where a pod can come and go. Service is long running. And this is where I get the load balancer right here. And these are all some of the labels which tells me which pods are connected to my service. Okay, let me pull up one more YAML file right here. So this is the other YAML file, another deployment right here. And once again, you can see here, this is the second image that I have that I created. This is the second Docker file I showed you. And once again, I'm sending this image to the Windows node pool right here. Okay, and there's some configuration settings that I'm setting here as well. Okay, so we have seen this part right here. Let's just go back to the browser. And right now here, this is my Kubernetes cluster. I have many different namespaces here. I want to go to the music store namespace. And if I go to this namespace right here, you can see the number of pods that I have running. These are all the pods that are running. And if I go further down here, these are all of the deployments that are running. Okay. And I can come in here and say, hey, scale my deployment to 2 right here. So you will see that Kubernetes has started another container for me automatically. Okay. And if we come back here, you will see that a new pod is being created. Okay. And if I go ahead and delete one of the pods, so let's just go ahead and delete this pod here. And if I delete this pod, you will see that by virtue of me setting the deployment property to 2 right here, Kubernetes noticed that I have, one pod disappeared, maybe because the hard disk failure or because it became unhealthy, and Kubernetes immediately started my pod again in this instance. So remember, I was talking about low cost of ownership. I have just on this one cluster, I have many different applications running right here. And you can see this pod came up for now. See, even though we deleted one of the pods, 32 seconds later, this pod came back right up. So this is really a powerful capability that you can take advantage of. Okay, so let's go back to the slides and let's talk about a couple of common pitfalls that you need to understand here. And I just want to look at the time. I still have about 4 or 5 minutes left. So I want to cover maybe 2 or 3 slides, just some of the common pitfalls. So notice that you cannot run any UI. Containers are headless, no RDP support. If you're talking about a persistent strategy, you will have to think about a volume. And if you're running inside AKS, you can mount a volume which can be an Azure disk or an Azure file. Let's talk about the authentication strategy. And this is a common question that I get from people, which is, so how am I going to manage the identity, right? Because on the Linux side, you have this unique identifier, which is specific to a container image. Of course, on the Windows side, we have a security database with every Windows image. And typically what we do is we take our virtual machines and we connect it to an Active Directory, right? So the common question I get is, so I can get a bit longer. Okay, thank you for that. Okay, I'll slow down and maybe explain this. I appreciate that. So the common question that I get here is that I have a Windows container, and I don't want to use my local security database. I want to be able to use some Active Directory authentication because I want to open a trusted connection to a database because my database is expecting that. How will that work inside Kubernetes and Windows containers? Okay. So this is an interesting problem that the team that was working on Windows containers was having, because keep in mind that these containers have to be really quick to start, right? I showed you an example. Remember, if I go back here, I showed you an example that this came up in a few seconds, right? Imagine if this container had to be domain joined. Not only would have the container come up and it has to start synchronizing all of that identity with Active Directory, and then that would not work because containers can come and go very quickly. So what they ended up doing was, there is a notion called the group managed service accounts in Windows, where you can have your node essentially be domain joined. So remember the green box and the blue box that we were talking about? So in fact, let me actually bring up this will make it really easy. So this is the identity that I'm talking about. So let's say you're running a container with ASP.NET and IIS. You want to talk to SQL Server. You want to not send the user's identity. You want to take some sort of a service account here. If you wanted to, in the container world, this gets really complicated here because you're running the container on top of container host. And this is where something like a group managed service account comes into play. And the way the group managed service account works is you take the container host, you domain join the container host, and then the containers that are running on that host can take advantage of the domain join nature of the host. Okay, so so basically what will happen is I can take advantage of a container which is enabled using group managed service account. So next time the user comes in, I can, basically what is happening is right here, my Windows Server VM is joined to the Active Directory. And in this case, I'm going to get that identity as a container. I'm going to take advantage of that identity. And I'm going to make a call into SQL Server. And that SQL Server, I don't have to then specify user ID and password. So think about that. That's one other important consideration. Let's talk about some of the current limitations with this approach right here. What are the things that are not available to you? So first and foremost, AKS is using host-only version and the process isolation mode. Remember, I was talking about Hyper-V isolation that's not available today in AKS. You can use disks and files are the only ones supported as the volume types. That's the other thing you have to keep in mind. AKS clusters. So, there's this notion of CNI, or the container networking interface. So when your Windows containers is coming up, it is going to get an IP address of its own. Where is it getting that IP address? It turns out that Kubernetes has an extensibility called the container native interface. Using that Azure CNI implementation of the container native interface, Azure CNI will go and try to get you an IP address based on your, if your cluster is being deployed to a certain virtual network, you know the address range of that virtual network, and it will try to get an IP address from that. And that's how you're getting an IP address. Now, the reason I'm citing this as a limitation is, if you're working with the Linux containers, you're probably used to also using another type of CNI plugin called KubeNet. That is not available as part of the Windows containers just yet. You have a limit of 10 nodes in a node pool. So, and then there is a certain limitation of how many pods you can run per node. So you have to think about it. If you really want to scale beyond that, then you have to maybe split your workload into multiple clusters. The network policy and KubeNet, as I mentioned earlier, are currently not supported. So on the Linux side, Microsoft enabled a capability where, if you are familiar with this notion of an Azure policy in Azure, which is a concept not related to Kubernetes, but it is a concept where you can apply some best practices and in a policy-driven manner. And that support is available for Linux containers. It's not available yet for Windows containers. And then I talked about the group managed service account. That's a way for you to do sort of system-based authentication, but GMSA is not yet supported by AKS. Now, keep in mind, these are early days. The AKS support for Windows Container went GA on April 28, so you can imagine that these capabilities are coming as well. Okay, so I think I've covered the limitations, a couple of things. I think I already talked about this. This might get you, and this is, I've run into this problem a couple of times. I have a mixed mode cluster, and I'm mounting a volume. And of course, you have a mixed mode cluster, you have a Linux cluster, and you have a Windows cluster. And of course, the backslashes are different. The file permissions are different. So you have to think about those kinds of things here as well. So with that, I just want to make sure, I think I've covered the key things that I wanted to cover. So this, maybe the last two slides, and then I'll hand the control back to our host, who has been very kind to me with all my technical difficulties that we're having at the beginning of the session. Apps make sense for you, okay? So if these applications are a slam dunk, web applications, IIS, WS service, this is a slam dunk. MSMQ applications, I think this is getting better. MSMQ support is there. But if you're trying to do something trying to run a print server or DirectX or Exchange server or something like that, that is still going to be problematic. Okay, I think I've covered most of these issues at this point. I'd like to take a pause, see if there are any additional questions. And I know that I've gone up by 3 or 4 minutes already, so I appreciate everybody giving me these extra few minutes to talk through this content. Let me pause here and see if there are any questions. And what I'll do is I'll make this slide deck available, and I'll also make the source available so you can go through this code at your own time. So Gregor?
Yeah, just to interject, there is a 1 hour long break now. And since this is an online conference, the time restraints aren't as important. So if people want to stay and ask a few questions, we do have time for that.
And I'm happy to stay. I'm available. It's only 6:30 in the morning here, so I have the time. I think there was a question there, so let me just go and find it. I'm very thankful, Gregor, to you for testing with me just before the session started. And looks like the internet connection stayed up pretty well for the presentation, right? I'm assuming that was the case.
Yeah, it's been very good.
Good, very good. Okay, so let's see. Let's go over these questions. Will the slides be shared? Absolutely. I will make sure the slides are available right after, and in just a few minutes, I'm going to make my slides available. And the example code, I need to do some cleanup, but I will put it on my GitHub link and you will have access to the code as well, right? Okay, so thank you that you like that explanation. I appreciate that. You mentioned C++ with P invoke. Is it different from C++ CLI? Okay, so I am